Hello and welcome to this episode of Microchips, and on the bench today we have a Ham International Concorde. Yes, just a Concorde, not a Concorde 2. It took me a while to find one of these, but now I have one. Let's see what it's all about and see whether we can make this radio great again. But before we start, don't forget to like, share, subscribe, comment, join Facebook group, join Patreon, buy me a coffee, have a look at my website microchips.net where all my boards and stuff is. And let's get started. So let's have a look inside. So I bought this as working-ish, out of a deal with some radios. Anyway, let's see what we can find inside. So, no date code on the PLL, not a problem. First things I noticed, the potentiometers for the carrier balance have fell apart like normal. That's not a problem, we can deal with that. And it's an 059 board. But what's more concerning is the lack of screw in the output transistor. Or is the screw just broken? But that poor 1969 looks like it's been running red hot. Yes, the front of the plastic screw's broken off, and obviously the transistor has not been able to sink the heat away. And yeah, the colour of that transistor means it's been getting toasty. So, just have a look on the underside. Having a quick look round, see if everything looks okay. And yeah, everything looks fine. Apart from it looking a little bit rough on the outside, inside is not too bad at all. So yeah, 059 for you playing along at home. Everything looks good. Now looking at the solder on this output transistor, this thing's been getting really toasty. I'm surprised that poor 1969 hasn't decided to fail. We're looking at the service manual. We need a 1K and a 10K for the carrier balance. We can sort that out. So I've unscrewed the heatsink for the output transistor, and as you can see the heatsink comes out and leaves the output transistor in place. So we shall remove that. So with our trusty vacuum desoldering, we'll see if we can get this cooked solder to melt. If the solder doesn't melt, a little bit of flux sometimes works with this. But it is coming off, so yeah. But yes, we're going to have to check this 1969. Make sure it's not failed after all that heat, because it definitely can't have done it any good. So we'll carefully lift the legs up. And we will carefully remove the transistor. As you can see, that thing's been getting rather toasty. Whilst we're in there, we can do the bias resistor as well. Makes it nice and easy to get to. And we'll do these carrier balance pots whilst we're desoldering. I'm going to do them both because, you know, why not? You can see they look a little bit tarnished. Looks like they've had a bit of a hard life. So, in with a 15 ohm resistor, and then we can adjust the final bias correctly. So yeah, nicely into place. Let's have a look at the transistor on the transistor tester. And it's still reading as a transistor, which is nice. and it shows we've got a diode across it, which is absolutely correct. So it looks like the transistor has survived. So we will be putting that back in again once we've corrected the heatsink. So what we've got is a metal screw, an insulating washer, and the insulation to go around the screw. And before we put it back in again, we'll just check for collector short against the metal frame, because we'll only be putting it in with it touching. It will be very unhappy with that. So that's the transistor nicely bolted, screwed to the heatsink, and we'll put some new plastic screws in the side to hold the heatsink into place. Well, the one problem with these plastic screws is they're not magnetic, but you know, you can't have everything. So there's our transistor again, and we will solder that back into place, and hopefully this transistor will live to see another day. But before we do anything serious to it, we need to just check the bias, put it to 0.7 of a volt. Okay, that's nicely soldered into place, that's not going anywhere. Excessive use of solder, fantastic. So the next job, let's put our 2 potentiometers for the carrier balance. Now these blue ones aren't a direct fit, they do flap about a bit, but once you get them into place, they're okay. I mean, really we should go through all the potentiometers in the radio, because you know, they do fail, they do get dirty. And there we go. And again, we will solder those into place. Just like so. Absolutely fantastic. That's another job off the list. So next we're going to replace the VCO, because this is a 059 board with the earlier type front board. The FM modulates the crystals and causes it to be muffly, and yeah, not very good, and when you shout it changes frequency and all that. So we're going to apply one of my VCOs with the Varicap FM audio fix. So to do that, we need to pull out the old VCO, and also the VCO has got voltage feed as well for a nice stable 5 volts supplying the VCO, because you know, we need a nice stable supply for this. It only causes problems if it's not. Yeah, that should be our VCO loose. Let's give it a push, and yep, it's coming out. Okay, fantastic. Then we'll take it out. And there we go. Doesn't look messed with at all, but it's old. Needs replacing with something that's better. And whilst we're in here as well, we need to do C11, which is on the 10240 crystal, which is a tantalum capacitor, and this capacitor likes to go intermittent and cause you all sorts of strange problems with the 10240. So that's a 560 picofarad capacitor. I'm going to replace it with this nice polymylar one. It's always best to change this even if it's not faulty, because I have had actually one go faulty on me whilst I was using a radio, and I think I've got a video of that, when that was actually causing me issues. So yeah, good preventative maintenance. So we don't need those holes for the VCO, so we'll just cover them up. Whilst we're in here, we're going to start removing the parts for the FM audio mod. So this part that needs to come out is the capacitor that's on the FM deviation potentiometer. That needs to come out and be replaced with a different value. So that's that. 104 capacitor needs to go in its place, just like so. There we go, nicely in place. And we'll solder that in. And that yellow and white wire, that's the audio coming from the audio amplifier that feeds the FM audio. Now next thing we need to do is link out R26, I think it is, and the easiest way to do it is just scratch a little bit of the solder mask back at this point, and we can add a blob of solder, effectively shorting the resistor out. So a little blob of solder there, link across, done. That's all that needs to be done to link out that resistor. Now I need to remove two more components which feeds the FM audio into the crystals and its associated varicap diode. So I think it's L3 and C30 that need to come out. And that will isolate the FM audio path going into the crystals. And they're buried underneath all this wiring. So there's C30 and there's L3. It can come out. And we can cover those holes up again, but we can leave one hole open because we will need that to take the FM audio into our VCO. So everything's looking good there. And we need this point, which is the supply. So there's our VCO with voltage feed and the FM audio varicap and capacitors. So we'll carefully install this into place, just like so. VCOs are available on my website or via the Facebook group. We'll quickly solder this into place. We don't want to leave the heat on too long. Due to the pins being soldered onto the VCO, we don't want them to start melting on the actual VCO side. So nice and quick with the soldering iron. Fantastic. We'll cut off the excess. That's our VCO fitted. So the hole we exposed before is the 8 volt or 9 volt AVR supply, so that can go in there, and that will feed our voltage to the VCO and the regulator that's on the VCO. And if we wanted, we could remove those two variable resistors, RV1 and RV2, if we wanted, and the white wire goes into that position, which is the junction of R26, I think it is. So basically that's taking the FM audio as it comes in from the audio output transformer through the variable. Now the next job for this, the SO239 socket was really loose and really crusty, so we're going to replace it with a nice new one. It was really slack and being intermittent, and yeah, for the amount of money it costs to replace one of these, you know, might as well do the job properly. Of course, this has been an absolute pain to remove. There we go. So we've got connections to the SWR board, and we've got connections to the frequency counter output, I think it is, if it's got one. We've got some caps that need to come off as well, and we'll be reinstating those once we put our new socket into place. Of course, Cybernet and the Wisdom have wrapped the wire around the centre pin and made it really hard to remove. But there, it's done. So we will remove this old crusty socket, and we will be replacing it with a new one, just like so. Now the bleep has got this strangeness going on that doesn't really work that well, so we're going to restore it back to it should be. So on the VCO test point, we're just going to go low, mid, high, set the VCO voltage, channel 1, channel 40. Get that set nicely. Yep, fantastic. So the radio should come to life now. So we're on the 10240 test point. We're going to adjust the 10240. We've got it nice and close. Just a couple of hertz out, so that's fine. I think the service manual specifies like 20-30 hertz. This will be the test point for the 10695 and 10692. So we need to make sure that those are correct for the LSB, USB, and well, basically everything. So in USB mode, it needs to be set to 10695. One of the controls is very twitchy because we are pulling the crystal to get it up to the frequency. Now on to the 10692. Yep, that's good enough. So transmitted frequency, you can see it's a little bit out. Now this is the clarifier in and out, so this needs to be adjusted, because when you turn the clarifier on and off it jumps. And this is a common issue with these, this radio should we say. So I'll show you how that's done in just a sec. But we've got the clarifier on and off working, so that's a potentiometer across these points, and we need to set it in a certain way with the, I think it's the clarifier out, and then adjust it, but we're putting it across. So now to check the drive strength out of T1 from the oscillators. I think this is TP3 we're in. As you can see, the drive strength was quite low down on that. Now as I was messing with it, you see the segments starting to flicker, and we all know what this means. This means a dirty rotary switch for the display. So it's only on the 41 to 80 wafer, but seeing we're not getting rid of this, we're going to be keeping the radio as original as possible. It needs to be addressed. So what we're going to do is do the absolute pain of a job and remove the actual channel change, which means unsoldering the 1 to 40 and the 41 to 80 wafers, carefully lifting the board off just like so. And we've desoldered the PLL side, and then we gently remove it from the radio. So to get to the dirty part, we've got to take it apart. So what I've done is I've marked the side of the channel change with 1, 2 and 3 with an arrow, so we know which way round they go. So we'll bend these retaining lugs, and we will gently prise the back retention piece of metal away to expose our wafers. Now, I need to be very careful with these to make sure they go back in exactly the same way, or else it's going to cause us problems. So I like to take them off in a certain way and then put them back on a certain way. So we will do that. So like I say, I've marked it. So first one off. So that'll be the PLL wafer. And that'll be the other, which one's that? The one at the front, so the 41 to 80 wafer. So whilst we're in there, we're going to give this a little bit of lubrication, because if you remember the high gain 5 that I did, where the grease had all congealed and was causing the actual rotary shaft to be very, very sticky. So these just clip together, so we've got to remember not to drop them, not get them mixed up, and make sure we put the centre part back in the correct way. So we're going to gently prise this apart. Being very, very careful. And it's being a little bit harder than it should be. But there we're taking it apart, and as you can see, our disc inside is quite tarnished. So we've got some switch cleaner on a cotton bud, and we're going to go over all of the contact area, just like so. I'm trying to keep this in a certain way so I can put it back correctly. So a little bit more switch cleaner on the cotton bud, and I'll go over it with a little bit of WD as well, just to add a little bit of contact lubrication. And we're going to clean the fingers as well. As you can see, I've just got contact cleaner in a spray can lid, and going with the flow of them as to not to bend them, because if we bend them it's going to be game over. So just as a last touch, we're just going to add a little bit of tension back into them. And we can reassemble it. Now, all being well, it should go back together again. And we should have correct channels. And everything should be fine. See, that one's not got a lot on it, whereas the other one had quite a lot on the other side. So, a little bit of a fiddly job. Now, get it back together, click it back into place. Now, all being well, everything should be fine. But what I didn't show is that I'd actually dropped one of them, which is going to come back and bite us in the backside. So we'll carefully put them back onto the actual channel change itself. Just needs a little bit of adjustment to get it to slide back on. Making sure we've got the right one in the right way, which we haven't. There we go. So the middle one is the PLL wafer, and that was the one that I'd dropped. So yeah, it's a very fiddly and tedious job, but you know, it's only switch contacts. And we'll reassemble it and put it back into the radio. So we'll put our retention bracket back onto the rear, twist our lugs round, and let's put it back in the radio. This part is absolutely fiddly as anything, because these pins do not want to line into place at all. So that's why I've had to slacken the front off to give me a little bit more clearance and a little bit of movement, just so I can get the actual channel change into place, and then it's just a case of feeling it going into place. And this one with the 2 wafers is even worse, but you can see these, so a little bit of eyeballing on the contacts and we can get them in place. So let's solder it up and see whether it works. So channel 41 should be 27415, and guess what? It's not. It's a whole 20 channels out. So that means we've got one of the wafers 180 degrees out. You know what that means? We've got to take it all apart again and correct the wafer. So yeah, 20 channels out, fantastic. Let's take it apart again. So you can see 27415 is on channel 61, whole 20 channels out, great. So let's fix that. So again, desoldered it, we'll take it back out again, undo the retention on the back. Now we know which wafer is going to be out. It's going to be the middle wafer that's out, and all we have to do is rotate it 180 degrees. We're not going to rotate the whole thing, we're going to slide off the actual wafer and we're going to rotate the centre part 180 degrees. So that one was correct. This is the one we need to fix. Yep, that should fix it. And back again, put it all back together. Getting quite good at rebuilding these now, so yeah. Anyway, that fixed that. So let's have a look at this dodgy beep. So we're going to get rid of these parts that have been added, and we're going to restore the beep back to normal. It must have been some beep on and off. Never seen it done that way before, but I've seen some strange things in some radios, so nothing surprises me. So we'll get that out of the way. We'll put that back onto there. Of course the other one jumps off as well. Not having a good day today. So there, yeah, back on. There's our bleep restored. I've not put it on a switch. Nice healthy 13 watts coming out of that tired transistor. So there's no problems there. one of our last jobs is the AGC. So we're just going to adjust that, so we don't get any overloading on sideband and what have you. It's a nice easy adjustment to do. So flick it from sideband to USB, we get the correct readings as per the manual. Fantastic. And to finish it off, we've got some nice new screws. We've had the lids powder coated. Unfortunately, not done anything to the front, the actual radio front, because it's not in too bad condition. It's got some war wounds, but you know, I've seen worse. Gives it a little bit of authenticity. And there we have it. Channel change working, radio working, fantastic. So if you enjoyed the video, don't forget to like, share, subscribe, comment, join Facebook group, join Patreon, buy me a coffee. Thanks for watching, and we'll see you in the next episode.